talking about today is one of the largest projects we have called the Global Resource Observatory, looking at data and trying to connect that data into strategic decision makings for mainly country level. So that's finance sector and governments. And this is more of an economics-led sort of view of the world, along with mathematical modelling. And then we link that into behavioural science about how to encourage people to take up regulations and to put in place behavioural change programmes to engage the community. So taking a step back about what I mean by sustainable development, because while it's been around for around 40 years, as a general discussion within government, it still means lots of very different things. So looking at a key problem, the so what, why do we care more about sustainable development now possibly, such that it's leading to action, such that we are getting city planning that takes into account sustainability, or government regulation that's starting to take more account of sustainability than it did when this started in the sort of international discussion 40 years ago. So the systems view of sustainable development, it includes a number of different issues. Most of these are managed by different government departments, mostly managed by different businesses and the different asset classes in finance. So it's energy, food, water, land, metals, social mobility and health, capital availability and environmental loading, including climate change. So basically it's everything the society needs to perform and to grow the economy, although it's everything the economy doesn't measure or doesn't really include in the way that it operates in terms of strategic decision making, apart from possibly energy availability, and food is becoming increasingly important. So what we're trying to do is look at the interconnections between all of these things. Work on this has been going on for around 40 years as well, looking at how food, water and energy mainly interoperate, so how you can create biofuels instead of food on certain land to create more energy, how you can use energy to extract more water out of the land or use energy to grow more food, how much water is needed for food and what food does to water availability. So this interconnectedness is really important, and trying to understand some of the limits through that interconnectedness is what we're trying to develop. We've had some very interesting discussions with some of the large US banks and finance regulations who basically said if it was just an energy problem, we'd probably be okay. The energy markets would be able to price accordingly. We'd create innovation, we'd create alternative technologies. The problem with substitution there is then you move the problem somewhere else. So we need to start thinking in a systems way to really try and understand where the problems are and what the integrated solution potentially looks like. So my view on sustainability, and this is the presentation that I use for some of the large pension funds and governments in particular, is looking at global pressures. Why is this an important issue? Why is sustainable development still relevant? So obviously map of the world distorted by population. You can sort of see where people are. We basically like living in warm areas around the centre of the earth. No one really lives in Russia or Canada. I don't think we have any Russians or Canadians here at the moment. For some reason, the geographer who traced this plot thought lots of people lived in Antarctica, but they don't, so so no one really lives in Australia or New Zealand. But the majority of the population, Europe, China, India, US, some very large populations growing rapidly in Africa. So you can sort of see the mix of population, so where some of these big issues are going to be discussed and thought about over the next 40 years. So what's happened since the Second World War, when we started talking about sustainable development in around the 1970s, life expectancy everywhere apart from sub-Saharan Africa has been going up. So our economic development and our activities as a society has been doing something right. We've been able to increase our life expectancy, and there are lots of reasons why sub-Saharan Africa has been going down. But life expectancy has been going up, so we've been getting older. Also, we've been, until very recently, having a significant impact on poverty. So this is households with an income less than $1.25 a day, the sort of World Bank absolute poverty measure. So this is showing some very significant declines, in particular, sort of light blue line in the middle, which is mainly China, apart from, again, sub-Saharan Africa, which is the dark blue line, which is staying above 50%. But everywhere else it's coming down fairly significantly, so we've been getting older, and basically healthier to be able to live longer, but we've also been getting wealthier on average. That's obviously not necessarily spread equally around the world. But this is a sustainable development talk, so while we've been doing a lot of positive things with our economic development, then the sustainable development challenges have been growing. So this is the projection of water availability around the world, sort of similar sort of map looking at water stress, and this is by the middle of the century, so by 2050s. And you can see this is where current economic activity and planned economic activity will be severely under threat due to availability of water. So Middle East, North Africa, large parts of China, sort of breadbasket of the US, and where we are currently in the UK, so east of England and southeast of Spain in Europe, significantly under water stress. Basically not enough water to continue to do the economic activity that you want to carry out. So you need to do something else. Water is fairly essential. So that's an investment challenge, it's an innovation challenge, or it's a move people out of the way of problem challenge. Soils, so how we use our lands to grow food. This is a current plot of human-induced soil degradation, so where we're putting our soils under stress. The red lines are where they're currently under high stress, down to the sort of green lines of stable land. But you'll notice that the sort of grey areas are either unproductive anyway, or they're not used currently because they're frozen. But there are serious implications for soil quality, so the productivity gains in food that we've been gaining globally over the last few decades. There are some questions around how we can continue to increase productivity at the same rate, whether that's possible. The other issue, and this is some of the things that we've been trying to understand more about at the moment, is resource constraints. So this is just a plot of the best estimates of resources left in the world for a few of the key resources that underpin some of our economic activity, divided by current use. So this has no economic increase, this has no substitution of technology, so it's just current resources. And there's lots of issues with the data about whether governments are overestimating, whether companies are overestimating, or whether they're underestimating some of the unfound resources, divided by the sort of current economic activity. So you can still see, and that's years left. So for oil, around 50 years left of current consumption. That includes some of the new sites, certainly the shale oil. Gas, around 60 years. Coal, 120 years, 116 years, I think was the latest projection. Uranium, 70 years. Silver, about 25 years. If you're in an industry reliant on indium, you have about 12 years left. Zinc, 45 years. Copper, 60 or so years. So lots of significant impacts over the sort of long-term strategic planning for certainly for governments and some investors who take a long-term view. But this falls outside most strategic investment planning. Although basically the story for that is things are getting more difficult to find, so they're getting more expensive. So it's not necessarily a case of immediately running out, it's a case of prices going up, and what does that do to the economy. The other side of things, obviously the environmental loading, and this is from the group in Sweden, looking at how much we're loading the planet. So the green circle is the nature paper. In the middle is how much the planet can naturally absorb and sort of recycle itself. And then the red line is where we currently are. So climate change, we're around 50% overloading the atmosphere, which is why we're seeing a temperature increase. Nitrogen cycle, mainly soils, we're way over. And the big red line at the bottom is biodiversity loss. So we're seeing one of the biggest extinctions, around 95% of all biodiversity being lost by the end of this century. So those sort of huge challenges are coming ahead. There are some interesting questions about what does that mean, especially for environmental loading. So climate change will have significant impact on some countries. It will have less of an impact on some other countries, but you can start to do some economic modelling. It has more of a sort of direct physical impact. Biodiversity loss is much more difficult to model. Does it matter if we lose 95% of all species on the planet? As a society, you can argue it does. As an economy, it's slightly more difficult to argue whether it does or not. It's more difficult to model it. It's easier to sort of qualitatively talk about the impacts of biodiversity loss. So how you interpret these, this sort of data and translate it into economics and finance and security risk is very interesting. The other thing that we're trying to put into the sort of data basket, and this is collecting all the data together to give you all of this information, is the sort of other limit to the sort of resource availability, and it's a limit of money. So I think there was a question about how you can raise the capital to invest in cities and developing countries. Well, this is the foreign reserves minus foreign debt plot from the CIA. So if you're in the US at minus $13 trillion worth of debt, or in Europe, then you're probably not in the best place. If suddenly all global trade closed down and everyone called in their debts tomorrow, you would have no money left to buy the resources that are increasingly scarce. China in positive, about $2.5 trillion. So where the money is and the global balance of money and flow of finance is also important to include as a potential limit to a particular resource. So the sort of summary of the data and the sort of very quick, rough look at data is that resources are getting more expensive, environmental damage is getting more expensive, and there's less money around. So taking those three things together, then there is a global challenge that needs to be thought about. These are the World Economic Forum Risk Registry, looking at all sorts of risk across the globe, and you see the majority of those are sustainable development related. They're either severe income disparity, fiscal imbalances, which you can argue is some of that sustainable development, some of it isn't, greenhouse gases, water supply, aging population, and then the impact ones are financial failure, so that's not necessarily a sustainable development one, but water supply, fiscal imbalances, food shortage, and then weapons of mass destruction at the bottom. But those are the top sort of 5 likelihood events and the top 5 impact events. The other thing just to think about as well is population growth and what that does to economic strategies at the political level. And obviously the projections from the United Nations and the World Bank are that population will peak around the middle of the century at somewhere between 9 and 10 billion. There are some estimates slightly lower than that and some slightly higher. But a peaking population also has a very interesting challenge for global societies. So when you're building infrastructure, and some of the cities that we've built have been around for centuries, if not thousands of years. So if you're building large infrastructure to cope with a population of 9 billion, if the population goes back down to 6 billion in 100 years after that, you've got a lot of empty cities. So we need to be thinking about flexible infrastructure over a really long time when you're building cities, because there will be far fewer people to live in them over a very long time. So there are some immediate short-term challenges we need to be thinking about, but a peak in population will also provide its own interesting challenge for infrastructure. It also provides a very interesting challenge when governments are led by GDP growth as a strategy, because you can't continue to grow GDP when you have far fewer people. You don't necessarily need to grow absolute GDP. You may want to grow wealth per person. So what does this mean? What are the latest the articulations of solutions to this or to these sorts of sets of challenges? We're sort of trying to review, and this is all in a big document we did for the Institute of Actuaries, so the sort of pensions and financial risk modelers. So this is growth as the solution, is carry on as normal, technology development, innovation. You just have prices coming through because of scarce resources, and we will transition naturally into the new society and the new economy that we need. And there are lots of articulations that we just need to keep the economy going. Green growth is a sort of variant of that, so you add on green economic thinking, so you add on some industrial policy, mainly to encourage renewable energy, to encourage sustainable city type planning, but you guide your growth more towards green solutions. Increasingly, in particular in the UK at the moment, but starting to have a bit more traction around some quarters in the US, as well as the end of growth. So if resources and increasing prices do provide such a limit that actually we have stable, flat growth, then it's reviewing back what does economic theory tell us about the implications of a constraint growth. So we have no growth globally. What does that mean for our societies? The main reason that we're having those sorts of discussions now is what's happened in the financial crisis. So we've had no growth for almost 10 years, but certainly for 5 years. And it looks like, certainly in a lot of the developed countries, certainly the UK, it's another 5 years or so. So you're able to have a discussion around what does a flat economy look like, and how you can operate and still encourage innovation and do the things you want with flat growth. The other articulation, which is what started some of the discussions in 1972, is the beyond the limits. So are we at such a state where we've created a society and an infrastructure that can't cope with the challenges that are coming up? So do we go beyond the limits and cause economic collapse in some form or another? The work we're doing is mostly interested in trying to understand how the beyond the limits would work out in practice. So the 1972 limits to growth work tried to do this at the global level, but the world isn't going to have an economic collapse from a global economic collapse. It happens in a much more nuanced way. It happens through different actors playing on the ground in different countries. So trying to understand what resource limits actually do to economies, or potentially do to economies, is what we're trying to do with the data. So what we're looking at, what we're trying to model, is put together all these resources with pricing data, with trading data, with economic activity, to look at what are the possible economic impacts. So could you get reduced economic growth? How reduced would economic growth be? Could you get reduced access to commodities and therefore increased price volatility, or even lack of availability for some supply chains, so you just switch off some supply chains? What does volatility do to international security and coordination? Do governments respond in such a way that they then try and encourage investments into particular sectors and discourage investments into other sectors? So do you get investment returns on particular sectors being repressed by governments in an attempt to encourage this green economy? And are there changes to life expectancy and morbidity? So what happens to the health of individuals? So the key challenge that we think is going to sort of drive some of the political instability is prices. So as resources become increasingly scarce, either from a demand or a supply point of view, then interesting things can happen around the world. This is the lots of research that's now gone on around oil price and food price being linked to an increased probability of civil unrest in North Africa for the Arab Spring. So there is a certain level, you can sort of see it's around $200 for the global food price index, where you get a number of countries going into civil unrest. It's not the cause of the civil unrest, but it's another additional factor which pushes people out into the streets to riot or to protest. And so depending on responses to that, you can quite easily see how political instability can come about because of something happening to the prices of food and energy. So looking forward, as food and energy potentially become more scarce, what happens to the food prices? What happens to volatility? Are these sorts of events more likely? How do you manage a society where these sorts of things are more likely, when in the past people have gone out on the street and rioted? And this is not just a question of the Arab Spring, but this is also true in most developed countries as well. There's been several smaller scale riots and protests around the world. The question is, what sort of political governance structure enables you to manage or to go through those sorts of political protests without losing the governments or without losing the societal structure around it? So trying to understand some of these future prices and the dynamics that drive price from a pure supply and demand issue, we think will have quite significant impacts potentially on political instability and financial returns depending on where your supply chain are. Building on top of that, you've then got the future projections from climate change and things like the environmental feedback. So this is a plot from the US looking at plant hardiness zones, so where you can grow crops. So what we've been trying to do is to look at asset value, so where the investors are investing, the sort of value they can extract from their products and their plants in the US, and modelling some of the asset value at risk from these changing climates. So the US, there's lots of asset value exposed, but this is certainly true all around the world, and in particular looking at things like cocoa plantations in Africa as climate changes and things start moving north or south, then you can get significant impacts on supply chain. This is a plot from the UK government, Ministry of Defence, trying to overlay some of these issues, so environmental stress, water stress, demographic stress, crop decline, so food, as well as water in terms of flooding on coastlines. Plotting on top of that a recent history of conflict, which is where you can start to model some of the propensity towards political instability. And so this is just not saying where they think anything's going to happen, but here's all the additional stress points that gives you a higher probability for conflict to occur. So this is their strategic planning tool for the types of technology they should be investing in. Because if you're looking at sort of Russia, then it's a different sort of technology you need to deploy in the battlefield than it is in Africa. So if there are more stresses coming up in Africa, then that's where they're looking for strategic assets and planning in the future. And this is a plot of current economic losses from natural catastrophes. Most of these are potentially climate change related. Certainly the probabilities are going up. There are earthquakes in there as well, and volcanoes in yellow. But the orange circles are extreme weather, the blue are floods, and the green are storms. So these are significant single events where this has cost the insurance sector lots of money. So looking at the economic impacts and the potential security impacts, trying to get the data together for that, linking it into the resource data, is quite an interesting challenge. But the reason we're able to start doing this is because there's been enough impact, and there have been enough losses and enough countries that have lost governments due to people going out onto the streets and rioting, that you can start to create mathematical models about it. So this is our Global Resource Observatory, just an initial pilot. What we're building is a systems dynamic model and an agent-based model. And an agent-based model is basically mathematical modelling where your agents are countries, so you're trying to model country responses. So how would a country respond to this global database of data? It's just an annual model, so this is a run of countries with their oil resources, how they're all linked together, how they trade with each other. So we're trying to model resource use, trade, and social outcomes. So we can look at scenarios. We can say, if we switch off the oil export from a particular country, what does that do to other countries around it? The interesting thing for a global economic collapse, which has been modelled in the past, and these sort of planetary boundaries, is that the world doesn't really operate on a global scale. It operates when a country goes into civil unrest. Syria has an impact on oil prices, increase of 3% in one day on oil prices. What does that then do to the neighbouring countries? Does that then escalate into a wider conflict? Does that increase the likelihood of oil prices going up further? Does that increase the instability in food availability in the region? Does that then have a knock-on effect onto neighbouring areas of existing conflict? Does that then become a global conflict? So through a sort of agent-based model, throwing in the 217 resources and prices and social demographics, can we start to see that interconnectedness and the way that you could start something off in a particular country that would then escalate into an issue globally over the next 5 to 7 years? So it's not a long-term issue. It really is sort of within political timescales. That's what we think is possible. Certainly when you're looking at the insurance sector, who look at 1 in 200-year events, it's certainly possible to bring down the entire economy with an event that only happens 1 every 200 years. So it's interesting to try and start modelling those. So our sort of outputs are a resource depth map. This is a resource depth map of oil. So this is just basically how many years are left in a very simple way for oil for each country based on their own consumption. So if this is, they stopped exporting, who has all the oil enough to power their own economy? And you can sort of see the usual suspects have lots of oil left. So this is the lighter colour, the light pink, have over 2,000 years left. whereas the darker colours, including the US, have less than 50 years left. On top of those sort of debt maps, you can start to get political risk maps. So how exposed and how likely a government is to be exposed to increasing resource prices, and what would that do? And then for industry, emerging risk reports, what does this mean for the insurance sector? What does this mean for investors? Trying to make this as accessible to public with transparent models as possible, and do regional case studies. So what does this mean? We're currently doing the Balkans in Europe. So the interaction of countries is sort of gives you the why and how this would disseminate out. So if one country had an issue, how would that link across? And there's lots of different ways of modelling the links between countries. Trade is the key one, obviously, but also politics, how connected politically are governments, as well as how fragile they are politically in their own right. And geography. If you're next door to a country, it's slightly more likely to have an impact on you than if you're on the other side of the world. So we're trying to develop these sorts of scenarios, and this is a set of scenarios we developed for pension funds. So looking at how governments and countries respond. So this is basically a government responding in a high sensitive way to resources or a low sensitive way, i.e. long-term thinking, more than 7 years. Low sensitivity is planning over a 1 year, 2 year time horizon. Markets are business doing the same thing, so planning over 7 years, or doing business over a 1 year, if not quarterly basis. So we're starting to build scenarios around how people would respond, what would that do to the model. And there's a whole, if you Google the actuarial model and the Global Sustainability Institute, you'll get your 250-page report, which came out earlier this year. I'm sure we can make it available, it's online. So using those scenarios, mapping them across to investment, looking at how governments would respond, what sort of investment returns you would get, and what that would do to pension fund returns. So this is looking at a sort of economic-wide impact. And this is just one of the outputs from that run that we had. And if you read The Guardian, then the headline they picked up on, so these are lots of different scenarios for the types of outputs you can have. The one they picked up on is obviously the orange line, which says that all pension funds globally will be wiped out in 30 years' time. So that is a very particular scenario. It's not a totally unlikely scenario, but it's a very particular scenario, and obviously for environmental press, they like things being wiped out in 30 years' time. But there are sort of no constraints. What pension funds are currently modelling is that black line at the top. So that's what they're expecting to be able to provide the investment returns that they need in the future. We can't quite get the assets to go up that high. So something's going to happen, but how this plays out in economic terms is very interesting. So the sorts of things we're trying to answer for business is, how does volatility arise, certainly in prices and resource availability, and does that lead to step changes in some of the financial or demographic variables they're looking at? The demographic is society. So does that lead to thousands of people starving to death for food? Does that lead to major riots? Are these correlated risks recognised in investment and business decisions? How can you start to build this sort of data-led approach into investment and business decisions, building actuarial and investment models that they can just use, building it into their finance decision, building it into insurance or into supply chain management? And are there big opportunities for proactive engagement over the short and medium term? So we do a lot of work with the UK government around climate finance in particular. So where are the opportunities for significant returns on investment over the next 5 to 7 years, if we think this is something that the world is going to take seriously and do something about? Thank you.
Thank you.